Hello jury, my name is Sunil and I represent DesignMate. Today, hereby through this video, I'm giving you a presentation which would cover a brief introduction about DesignMate, philosophy behind our product Eureka.in, and then a detailed demonstration of our product. So let me start with a brief over DesignMate. DesignMate develops 3D animated content for K-12 curriculum. This 3D content caters to those complex concepts of science and mathematics which are hard to understand through conventional teaching methods. Now before I move to the product demo, let me tell you a little about the philosophy behind our product Eureka.in. We observed that the biggest challenge for the education fraternity today is to engage the 21st century student whose life is surrounded by an environment full of visual and graphics from games, videos, movies and many other media to which he is exposed to in his day-to-day life. So to address this challenge of engaging the students in their studies, we use the innovative 3D technology to create an identical environment full of visual and graphics which could excite him the same way as his movies, videos and games. 3D with its high quality visuals and graphics bring an element of excitement and engagement, resulting into better understanding and longer retention. To bring this philosophy in the shape of a product, we created Eureka.in, a library of 3D animated learning resources like videos, simulations, images and games, all in the form of K-12 curriculum. So to introduce you to all these exciting learning resources, let me quickly take you through a guided tour of our product. The product comes in the form of different course packs for primary, middle and high school covering their science and mathematics curriculum. The teacher can access any of these course packs as per her need. For example, let me select the middle school. The product comes in a very user-friendly interface. As you can see, the entire content has been mapped as per the NSCS curriculum. Under middle school, you have got different subject categories like physical science, life science, earth and space science, etc. You can select any one of these categories like life science. Under these categories are given different subcategories. As I select one of these subcategories like structure and function in living system, I see various chapters coming under that subcategory. Further, when a chapter is selected like this one, it gives me various topics coming under it on right side. Now let me select one of these topics to introduce you to the product. This topic is physiology of digestion, which will explain us various organs involved in the digestion process. As I click this, it will take me to the animated video over this.
Physiology of digestion. To understand the physiology of digestion that involves ingestion, digestion, absorption, and egestion. When we eat food, it enters the mouth and is called ingestion. The food consists of various components, some of which are broken down by saliva into smaller particles called bolus. This bolus then enters the esophagus by peristaltic movement and then reaches a sac-like muscular bag known as the stomach. The stomach contains a few enzymes and hydrochloric acid. The muscular wall of the stomach helps in mixing and churning the food, which help to break down the bolus into a mass known as the chyme. This chyme passes into the duodenum. The pancreas and the liver are the accessory digestive organs. Liver and gallbladder release the bile juice, while the pancreas releases the pancreatic juice, which enters the duodenum through the common bile duct. The bile juice acts on the fat molecules, and the pancreatic juice acts on the food molecules and breaks them down into simpler particles. After this, the digested food particles move into the lower part of the small intestine. A sectional view shows numerous villi on its inner surface. The digested simple food particles include the useful molecules, the waste particles, and some water molecules. A closer look at a villus shows the blood vessels and the lacteal. The useful molecules get absorbed into the blood and the lacteal. This food is eventually transported to the various parts of the body, providing them with energy. The remaining unabsorbed waste particles and water molecules move further. These molecules further pass through the small intestine and finally reach the ascending colon of the large intestine. From here, it passes through the transverse colon to the descending colon. Most of the water molecules are absorbed by the walls of the colon, and the waste substances are collected in the lowermost part of the colon, known as the rectum, from where the waste substances are excreted out. Thus, the process of digestion is completed. To sum up the topic, we see that the complex food that is ingested is acted upon by enzymes in the stomach and broken into simpler food particles. Then, in the duodenum, the enzymes act on these particles and further break them into simpler particles, which now can be absorbed by the villi in the small intestine. This food is transported to the various parts of the body, providing them with energy. The undigested food and water molecules move into the large intestine, where the water molecules are absorbed by the intestinal walls, and the undigested food is collected in the rectum and finally egested.
Apart from passive learning resources like videos and images, we also make active learning resources like simulations, which give a chance to students to interact with these concepts and understand them better while they're exploring it. So let me show you the simulation of digestion. As I click on this button, it takes me to the simulation of digestive system. It takes some time to load. Okay, so now each simulation comes with introduction, objective, instructions to play with it, and the controls. Once I'm through with all of them, then I start playing with the simulation. Here I have a 3D model of the human body which shows me all the organs which are involved in this digestive system. With the help of the mouse, as you can see, I can rotate this and show my students each and every organ involved in this. To have a closer view of these organs, I can zoom in, then I can zoom out and further show my students all the organs involved in this. Now, to play with this simulation, I have been given instructions which I have to follow. So the first instruction is, click on any of the food items displayed. So suppose I select burger. As I select burger, it goes in my mouth and the first process of digestion, that is ingestion, starts. Now it asks me for the second question, that is click on the salivary gland. So I click on the salivary gland here, as we had seen in the video. So with my click, the saliva comes out of the mouth and it acts on the food material. And after this, I have my another instruction. From the option given above, click on the enzyme present in saliva. If I know that which enzyme is present in the saliva, then I can select from these options, and if I do not know, I can go back to the hint and can read out that which enzyme is available in saliva. So it tells me amylase is the enzyme. So I select salivary amylase and now I have my another question here. Move the slider and adjust the pH level. Now I have to create a pH environment here which can activate this salivary amylase enzyme. If I know the pH level, it's okay. Otherwise I can go to the hint and it tells me that the pH level has to be between 6.7 and 6.9. So I move the slider to make the environment alkaline, and which makes my salivary amylase enzyme activated. Further, it gives me another question. Drag and drop the enzyme salivary amylase on the starch molecules, which break them into these further molecules. So, as I can see in the legend, that salivary amylase is represented by the blue object and starch is represented by this chain of smaller blue objects. So what I do is, I drag the salivary amylase, I drop them on the starch molecules, which breaks them down into these two smaller molecules. So I have to drop it twice as the instruction says. So I drop it here. As I break down the starch molecules with the help of the salivary amylase enzyme, it takes me to the next process of digestion, that is digestion. So click on any of the food items to facilitate the transfer of all the particles to the stomach. So I click any one of these items, suppose this, and it will take me to the next process of digestion. As the food comes in the stomach, as we can see here, I have my another instruction here. Move the slider and adjust the pH to activate the enzyme pepsinogen. As I can see in the legend, pepsinogen is represented by this blue object, which is here, and as I saw in the video, it works in an acidic environment. So I make the environment in the stomach acidic, and as I make it acidic, the pepsinogen enzyme gets activated. And then I have my another instruction. Drag the pepsin molecule on the two molecules of protein. So I can see in the legend, protein is represented by the chain of yellow chain. So I drag this enzyme on the yellow chain and I leave it. So it breaks them into smaller molecules. Now click on any of the food item to facilitate the transfer of all the particles to the intestine. So I click any one of them, suppose this one, and it will take the food to the intestine. This is how you can follow the steps, you can follow the instruction to go through all the 4 stages of the digestion. You can play the full simulation of this topic from the demo CD link which we have given you. So this blend of passive and active learning resource delivers a deep understanding of concepts to the student. Apart from these, we also make some other learning resources which complement the learning received from video and simulation. So let me take you to our next learning resource, that is quiz. So coming to quiz, every topic comes with a set of questions which helps the student in evaluating his understanding over the topic. So let me attempt this quiz. I select option C. Food undergoes peristaltic. Cyclic structure involved in digestive system is this. Suppose I attempt only 3 questions, and after that I submit my question paper. After submitting, it shows me that how many have I done right and how many have I done wrong. For the wrong, I can go to the reason part, which shows me that why it was wrong. Apart from this, we have given the facility of adding the questions. So suppose I add a sample question. I can write A, B, I can write the options, and suppose I can select B as my correct answer and I add it. As I added, I can see at the end I have another question, I have a new question which is sample question, which I just added at the number 11. Similarly, we have given a facility of editing the question, deleting the question, giving the print of the entire set of questions, and resetting the question. Our next learning resource is web links. This contains the best links available on the internet over digestion. We have even given the facility to add your own links here. After this, we have got a image. After that, we have got key terms, the explanation of the key terms involved in the digestion process. And at last, we have given a facility of feedback in each topic which helps us in making our product better. So, the combination of these different learning resources completes one topic of digestion. And such, we have around 1500 topics, each having all the learning resources which I explained in the topic of digestion. So, you have already seen one topic from biology. Now let me show you one more topic from chemistry. This topic is electronic configuration and position of element. Like I showed you last, let's watch the video of this topic.
Electronic configuration and the position of an element in the periodic table. We all know that an atom consists of a central part called the nucleus, which contains positively charged protons and electrically neutral neutrons. The number of protons in an atom is called its atomic number and is represented by Z, while the sum of its protons and neutrons is called its atomic mass number, which is represented by A. Besides protons and neutrons, there are negatively charged particles called electrons, which revolve around the nucleus in various shells or orbits. This arrangement of electrons around the nucleus of an atom in various orbits is called its electronic configuration. Please note here that the number of electrons in an atom is always equal to the number of protons, which makes the atom electrically neutral. Every orbit has a certain capacity to accommodate electrons. The maximum number of electrons that can be accommodated in a particular orbit is determined by the formula 2n squared, where n denotes the orbit number. The first orbit, n, is equal to 1. Therefore, 2n squared is equal to 2. Hence, the maximum number of electrons that can be accommodated in the first orbit is 2. Similarly, for the second orbit, n is equal to 2. 2n squared equals to 8. Hence, the maximum number of electrons that can be accommodated in the second orbit is 8. Although the third orbit can be occupied by a maximum of 18 electrons, when 8 electrons are occupied in the third orbit, a certain degree of stability is given to the atom. Hence, the next electron, instead of entering the third orbit, goes into the fourth orbit. For example, the atomic number of potassium is 19. Therefore, there are 19 electrons revolving around the potassium nucleus in the potassium atom. Out of these, 2 electrons enter the first orbit, 8 in the second orbit, the other 8 enter the third orbit, and the remaining 1 electron, instead of entering the third orbit, enters the fourth orbit. Hence, the electronic configuration of potassium is 2, 8, 8, 1. The electronic configuration of an element also helps us to decide the position of an element in a periodic table. The number of orbits or shells denote the period to which that element belongs. Let's continue with the same example of potassium. Its electronic configuration is 2, 8, 8, 1. This means there are 4 shells in an atom of potassium, and therefore, it belongs to the 4th period of the modern periodic table. Similarly, sodium with 3 shells belongs to the 3rd period. Lithium with 2 shells belongs to the 2nd period. Rubidium with 5 shells is placed in the 5th period, and so on. The number of electrons present in the outermost or valence shell of an atom decides the group number of that element. Thus, potassium with 1 valence electron fits into group 1 of the modern periodic table. Magnesium with 2 valence electrons is placed in group 2. Aluminum with 3 valence electrons belongs to group 3, and so on. However, there are a few irregularities shown by some elements in their configurations, such as that for chromium, copper, silver, gold, etc., which we'll study in a separate topic. Despite these irregularities seen among the elements, it is possible to predict the position of most of the elements in the periodic table from their configurations and vice versa. Summary. We have seen that the number of protons present in the nucleus of an atom denotes its atomic number, while the sum of its protons and neutrons denotes its mass number. The atom is electrically neutral, as it has the same number of protons as electrons. The number of orbits in an atom of an element tells us the period to which that element belongs, while the number of valence electrons decides the group number of that element in the modern periodic table.
So this topic also has an exciting simulation. Let's play it. So like I saw in the last simulation, I have my introduction, objective, instructions and controls. Once I go through all of them, I start playing the simulation. I can rotate this simulation also. I can zoom out, I can zoom in. Now let's start playing the simulation. So I have my first instruction below. Click on any one of the blue spheres to find its electronic configuration. So I select this one. Now on the left hand side, I can see protons, neutrons and electrons. Now the number of electrons given here are 7. I have my first question or the first instruction. Drag the slider to give the correct number of orbits and click on check button. So as I saw in the video, the number of electrons are 7, so it will have 2 orbits. Let me check. And hereby I have my second question. Fill the electrons in the respective orbits by using the slider and click on the check button. So in the first orbit I will fill 2 electrons. Now I am left with 5. So in the second one I'll fill 5. Now let me check. Now it says click on the correct period and then group to find the position of given element. I know the number of the orbits define me the period number. So I select first and then the second period I have selected. And the number of the valence electrons, which are 5, tells me the group number. So first, second, third, fourth and fifth. I select the fifth. And now I select the position. So the element goes in the right position of its in the periodic table. Similarly, I'll keep choosing different blue spheres and I will keep fixing them in the right position in the periodic table. So this simulation helps us or helps students in identifying the right places of the element in the periodic table. Similarly, we have other learning resources like quiz, website links, images and key terms for this topic also. With this topic, I finished my demo and I hope you enjoyed it. If you have any query or wish to have any other information, please write to us. Thank you very much for your time and you have a good day ahead.